Right, welcome to today's live stream. We've got our first question here. They're all going to be exam style questions because essentially you're just using formulas and trying to problem solve with all these questions. So our first one, here we go, 3 minutes, off you go. See how far you can get with this one. Okay, so here's our first one for today. We've got this cylinder here. Okay, we've got this cylinder and we've got spheres on the ends of it. And we know the volume of a sphere of radius r is equal to 4/3 pi r cubed. So what we're going to do is we're going to work out, I'm going to look at the volume of all of this and then times it by 5/12 to get the water. So the volume for all of this, okay, there's essentially one sphere here. So the two halves added together gives you one sphere. So we've got 4/3 pi r cubed. And then we're going to add on to that this middle bit, which is going to be basically the end times the height. Yeah, it's just like a prism, this cylinder. So we're going to be plus pi r squared, which is the area of the end, times by the height to get the volume of that. And sorry, that's just gone hidden behind the label. So we'll just write that out again. So 4/3 pi r cubed plus pi r squared h. And so they're putting the numbers in. The volume we're going to have of the water, so the volume of the water is going to be 5/12 of this. So let's put 5/12 times all of that. And we've got 4/3 times pi. And r is going to be equal to half of 12. So it's 6 cubed plus pi times 6 squared. Now the height of this, that distance there from here to here is going to be 6. And this distance is also going to be 6. So we're going to take 12 off that, so that will give us a height of 9. So we times that by 9. So therefore we can actually save ourselves, if you were doing this as a non-calculated question, we can save ourselves a lot of work by taking some factors out. We've got 6 squared as a factor here, we've got 6 squared as a factor here, and pi. So let's take out the 5/12 times by 6 squared times by pi out, and that will leave me 4/3 times by 6, because I took a 6 squared out, and then I've taken the pi and the 6 squared, and that's going to leave me a 9 here. So let's just work this out. That's 6 squared is 36. Divide that by 12 is 3. 3 times 5 is 15 times pi. 4/3 times 6, well, 6 third of 6 is 2, times by 4 gives me 8, plus 9 gives me 17. And 17 times 15, well, you should know 15 squared is 225, so that's 2 more lots of 15, which is 30 to add on to that, so that gives me 255 pi, and that gives me the exact volume of the water, 255 pi in the capsule. Now it's rotated for 90 degrees, so it's on the end of one of its hemispherical ends. We want to find the height of this water. Now, the way we're going to do that is, first of all, I'm going to take away the volume of this half sphere, because it's not consistent what's going on. Whereas the depth, the area here is always consistent, so we can easily work out that height. So what we want to do, we're going to work out, take this away first, to get the volume for this bit here. So this bit's volume will equal the 255 lots of pi. Sorry, I've written 255 lots of pi. I'm going to take away from that a half times by 4/3 times by pi times by 6 cubed. And I can work that all out. I'm going to get, well, half of 4 is obviously going to be 2. And then we've got 6 cubed, we've got 36, and I've got 6 squared is 36, so I can put 36 times by 6, but I've got 3 into that 36, so therefore I'm going to have 2 times 36, which is 72, times by another 2 gives me 144. So it gives me 255 pi minus 144 pi for this bit here, this bottom bit here. So that will leave me 111 pi, and we know that that's equal to this volume here. So I've got the area pi r squared times by h. Now pi r is 6, so I've got pi times 6 squared, 36, times by the height will equal 111 pi. So therefore h will equal 111 pi divided by 36 pi. And that cancels down. And we can use our calculator to work that out. And when you divide one by the other, you get 3.08. Now that just gives me, we're going to be careful here, my h here is not the same as their h. That just gives me the 3.08. Now we know that the radius here equals 6. So their h will equal 3.08 plus 6. And to one decimal place, we need it is going to be 9.1. Right, our next question here for you to have a go at is this one. I'll give you 3 minutes to see how far you can get into it, and then I'll go through it. Right, here we go. Now the key to this question is to realise, just going to get my pen back. Right, the key to this question is to realise that what you have is you have an enlarged cone to find the value of this x here. So what you can see is that you've got the radius of the small cone is 6 and the radius of the big cone is 14. So we can find the scale factor is just equal to 14 over 6. So this length is 12, then the whole length, so if that length is 12, then the whole length here is going to be 14 over 6 times 12. So that's going to be 12 divided by 6 is 2, so 2 times 14 is 28. So therefore x will equal 28 minus 12, which equals 16. Now we're going to find the surface area of the frustum. Now the easy way to do it is to find the surface area of the big cone and then take away the surface area of the small cone. Then find the area of the two ends and add them on. So let's start off with the surface area of the big cone, and the surface area of the big cone is equal to pi RL, which is equal to pi times r, which is 14, and L is the whole length here, which is 28. So pi times 14 times 28. And then we've got the small cone, we've got 6 pi times 6 times by the length here 12. And then we're going to add on the ends. So this end here is going to have a radius of 6, so it's going to be pi r squared, so it's pi times 6 squared. And then this end here is going to be plus pi times 14 squared. And we can work those all out. And once we've done that, we get 28 times 14 is 392 pi minus, what's that going to be? Let me just check that. That's going to be 72 pi plus 36 pi plus 196 pi. And then we add those all up and we get 552 pi as our answer. Now we've got the cone of radius 14 has the same total surface area as this frustum here. So we want to find this slant height L here. So we know that for this one, the total area is going to be pi times r, which is 14, times by L, but we've also got to add on to that the end, which is going to be pi times 14 squared. And then that's going to equal to 552 pi. So that's going to give me 40. We can cancel out the pi straight away. We've got a pi everywhere, so we've got a factor of pi throughout. So let's just cancel those down. And that leaves us with 14L plus 196 equals 552. So therefore L will equal 552 minus 196 over 14. And for that we'll grab our calculator. So we get 552 minus 196 equals, and divide by 14, and that gives us 25.4 to one decimal place. Centimeters. Okay, 25.4. Right, next question. Here we go, one bit more algebra in it. Okay, see how you get on with your first 3 minutes on this question. Okay, this one looks a lot harder than it is. As long as you're consistent in what you're doing, you'll find it quite straightforward. So what we're going to do is we're going to write out each bit. We're talking about areas all the way through, and we've got the total area. So let's start off by writing out what the total area is from the cone, from the cylinder, and from the hemisphere. So the area of this cone, the curved area, is given by pi RL. So the total area is going to be equal to pi RL, and we know that because the height of this is x here, the radius of this sphere is x all the way. So the radius of the circle is x, and so the base of this cone has a radius of x. So my r is going to be x. So I got pi times by x times by the slant height, which is x plus k. And then I'm going to add on to that this middle bit, which is going to be the pi r squared times by the height. So it's going to be pi times x times by 2x plus 1. And then I'm going to add on to that the base, which is the hemisphere, which is got a surface area of 4 pi r squared. So, but that's a half of that, because the whole sphere is 4 pi r squared. So we want 2 times pi times r squared, which is x squared. And then I'm going to multiply out these brackets, and I'm going to get pi times x is pi x squared, plus k times pi x. Then on the next bit I'm going to get plus 2 pi x squared. And I'm going to get pi x times by 1, so it's another pi x. And then I'm going to get plus 2 pi x squared from the bottom bit. And something's not quite right there. Where have I gone wrong? Oh, I know I've gone wrong here. Okay, I'm sorry about that. The reason why I knew I'd gone wrong is because I got 7 pi x squared and I got 5 pi x, and I was hoping for one of them to match. And I've only got 5 pi x squared here, so I missed my pi out there. And I've only got the k pi, so the k is on this side, so this bit should be matching. Otherwise I'll be struggling to do this question. And what I realised is this curved area here is going to be the circumference, which is 2 pi r times by the height to get that curved area. And I only did pi times r, and I want a 2 pi r. So if I double that, I'm going to get 4x squared here, and I've got 2 pi x times 1. That means I'm going to give me another 2 pi x here. So if I add up all the pi x squareds, I get 1 plus 4 plus 2, which is 7 pi x squared. And then add up all the pi x's, I've got pi x k dots plus 2 dots. So I've got k plus 2 dots of pi x. Okay, sorry about that mistake. So what we can see is this matches up perfectly with this. So therefore this needs to match up with this. This is how many x's I've got. This is how many x's I've got. They must be the same. So 5 pi x must equal k plus 2 pi x. And straight away we can cancel out the pi and the x. Okay, pi on this side and pi on this side. Divide both sides by pi, divide both sides by x. They cancel. That leaves me 5 is equal to k plus 2. So therefore k will equal 3. Solid B is similar to solid A. And side B, lengths B are double the lengths of side A. So that means the length scale factor is equal to 2. So the area scale factor, remember from previous video, is going to be equal to 2 squared. So that gives us 4. So basically the areas here are going to be 4 times the areas here. So 4 times 7 is 28. And 4 times 5 is 20. And that gives me the answer to that. So the last part was really quite straightforward. And it shows that you shouldn't just give up because if the first bit's hard, sometimes the last bit, always use the information given the first half to try and do the second half of the question. Right, moving on to our last question for today. Give you 3 minutes to have a go at this one. Okay, so we've got a square base pyramid that has a base length of 8 centimetres and a surface area equal to 144. So it means the whole surface area is 144, not just the base of this. Calculate the length of the diagonal of the base. Well, that's quite straightforward. We know we've got a square, 8 and 8. So therefore, to calculate that diagonal, we've got a right-angled triangle. And we've got side 8 and side 8. So therefore x squared will equal 8 squared plus 8 squared, which will equal 64 plus 64, which equals 128. So x will equal the square root of 128. So grab our calculator and we do square root of 128 and you get to one decimal place 11.3. Now we want to calculate the angle between any sloping triangular faces and the base, this angle here. Well, the key thing, we know this length here, and if we drop down, let's just grab a red pen so it's easy to see, we drop down this vertical down to middle, because it's a square base pyramid and the actually, it doesn't actually tell us that all the triangles are exactly the same. Okay, because all the triangles are exactly the same, and the top of this is over the center of the base, we get a right angle here, and we get a right angle here. And this will be halfway along, so that distance will be 4. Now, we can find out this distance by using what we know about area. Because if we take this triangle here, what shall I use? I use green to show the triangle. So this triangle here, and draw it out. Okay, we know that's the height of that triangle and the base is equal to 8, so half the base is 4, so that's going to give me the height of that triangle. And then we can find the area of this triangle is obviously going to be 4 times h, half base times height, so the area equals 4h. So the area of all the triangles, so 4 triangles, will equal 16h. And that's going to equal 144 minus the base area, which is 64. So 16h will equal 144 minus 8 times 8, which is 64. So therefore h will equal 80 over 16, which equals 5. So we now know that distance there is 5. So we have this triangle here. So I want to do taking this triangle here. That's 5, that's 4, there's my angle theta. So I've got adjacent and I've got hypotenuse. So cos theta equals the adjacent 4 over the hypotenuse 5. So theta will equal inverse cos of 4 divided by 5 is 0.8. Grab your calculator for this. So cancel that and we do shift cos 0.8 and we get 36.86. So that's equal to 36.86 degrees and so on. And we want it to 1 dp, so it's going to be 36.9 degrees. Okay, now if you found any of those a bit tricky, you ought to go and practice them some more. And remember, they're all in My Maths, all these things. So if you've got a subscription to My Maths, you go into My Maths Revision Assessment. These are the booster 6 to 7s, and I think this is the properties of shapes. And you can just do them for practice. Wrong one, sorry, not the properties of shapes. It was further on. Perimeter, area, and volume, that's the one you're doing. So there we go, perimeter, area, and volume. I'll put the link to this into the notebook for you after the end of the video, and you can see you can just do the questions. They change the numbers slightly to make them slightly different, so you can work through this with the video to help you. Okay, and now tomorrow I'll be doing some level 8 stuff on sine, cosine rules with 3D trig and stuff. Thank you very much.